So before I even do anything on here, you do get a calculator for this unit. So can you look though, because if you don't get this, all your answers are going to be wrong. Not trying to like instill fear into you, but sort of, okay? So I'm gonna share my screen. We're gonna open the Desmos. Everything we're gonna do for this unit is gonna be in degrees. So you have to come over here to the little gear. Radians, which after this unit, we're going to switch over to radians and it's all going to be radians. But for this unit only, it's degrees. Radians is the default setting. Do you see that? So you are going to have to put it back in degrees or literally everything will be wrong. Is that clear? Yes. Okay. So I just went and changed that first. All right. So Pythagorean theorem. I mean, I am teaching you this, but I feel like you might know it, right? Let me just throw the question out there. What is your Pythagorean theorem? There you go. See, because even if years from now you forget everything else, you're probably going to remember that, right? Like you're never going to forget all of it. Now, there are certain ones called Pythagorean triples. I call them the locker combination ones. For hopefully obvious reasons you'll see. There's a few of them that I can't force you to memorize, but it will help you if you know them. The first one is 3, 4, 5. And if you don't remember any of the others, can you please remember 3, 4, 5? Like, can you do that for me? Now, you can also scale them. So, for example, if it's 6, 8, 10, do you see how I just took all those numbers and doubled them? Same thing. It's a 3, 4, 5 triangle that just got doubled. Okay. Another one is 5, 12, 13. You got 8, 15, 17. And 7, 24, 25. There are obviously more because numbers are infinite, right? But those are the 4 that I have memorized. So I'm sharing them with you. It's just helpful if you have those in your back pocket and you'll see, because then if they come up, you don't have to do any work. It's less work for you. All right. So let's go ahead and give this first one a try. You can call the missing side kind of whatever you want. I usually go with A, B, or C if it's the hypotenuse. So I'm going to call this A, and we're going to just set it up. So A squared plus 4 squared equals 10 squared. And basically then you're just going to work that out if you all want to kind of do that at your own pace, and we'll just make sure we end up at the same spot at the end. That's 16. That's 100. You would subtract 16, so that's going to be 84. And then when you square root, you have to split up your square root. Well, if possible, I guess some of them don't work. Like if it was square root of 21 or something, you couldn't do that. But what perfect square is going to go into 84?
Oh, wait.
I need a perfect square. 9 won't go into 84, but you're in the right spot now. It's actually smaller than that. 8 is not a perfect square. 7 is also not a perfect square. Okay, let me stop us. That's correct. But hold on. Can we talk about what a perfect square is? Because I just learned that you don't know what that means. A perfect square is a number you could square root. So let's talk about them. 4, 9, 16, 25, 36, 49. Are we all together now? Okay. It is 4. And then it'll be 4 times 21. All right. And then the whole point of choosing 4 is you can actually do that one. What is your square root of 4? 2. So 2 square root of 21 is your final answer. Let's try it again. So no, and I was waiting to see if somebody did ask that. The reason we don't do plus and minuses for these square roots is because they're sides of triangles and a length cannot be negative. That would be like an untriangle. So you don't even have to worry about that. All right, so I'm going to call this A. You can call it X if you want. Call it whatever you want. You're going to have A squared plus 7 squared equals 15 squared. So that's 49. And does anyone know 15 squared? Yeah, and you will get a calculator for this unit, but I was just throwing it out there. All right, we're going to subtract 49. I'm just going to tap that in real quick so make sure I don't do it wrong in my head. It is 176. Good job. And then when you square root, you're going to have to split that. I think 4 goes into 176, or is it, you want to try 16? Oh, it is 16. 16 times 11. I just typed in the calculator 176 divided by 16 and it came out to 11. Like you would just noodle around with it. 176 divided by 36, 176 divided by 81. Do you get what I'm saying? It's division though, right? And then what's your final answer to the whole thing? 7. Oh, my son's birthday is 4/11.
Aw. Oh, it's coming
I
up.
mean, I did that on purpose. Yeah, it's always like kind of close to Easter. All right, and then this one, we should not have to do any work. It is 5, 12, 13. And see, that's where those come in handy, is it saves you work. You have to do work if you know the answer. 16 times 11 is 176. We just split it. Yeah, we just had to, we had to crank the gears. I like that. Okay, now we're gonna do two special right triangles. The special ones. So first one, 45, 45, 90. And if those two angles are congruent, it means these two sides are also congruent. So instead of A, B, C, you have A, A, C. Do you see what I'm saying? They are congruent. Do you remember what congruent means? It means equal. Are you having flashbacks to geometry? Is it good or bad? But okay, well, see if I can get you through it. All right, so instead of A squared plus B squared equals C squared, we're going to have A squared plus A squared equals C squared, and then just kind of boil that down and see what we end up with, because it's one of these special patterns. Good, that's where I was headed. It's 2A squared equals C squared. And then what you would do is square root. Now you can't square root 2. I mean, you can, but it's a weird decimal. It's 1.4, and I only know that because I live in this room and do math problems. Okay, so it's going to be square root of 2 times A equals C. That's your first pattern you get out of that. So if you take the smaller side and multiply by square root of 2, you get the bigger side, the hypotenuse. Do you see that? Multiplying gives you the bigger number. If you do that backwards, if you take C and divide by square root of 2, you get A. So to get to the bigger side, you multiply. To get to the smaller side, you divide. Let's try a couple down here before I show you the other one, because I don't want to overload you. Okay. So looking down here, do you see how these two triangles are 45, 45, 90? Is the 45? Oh, do you guys know how many angles are in a triangle? Just throwing. I said that wrong. Do you know how many degrees there are in a triangle? 180. There we go. I misspoke. I was like, there are 3 angles. Yes, obviously it's triangle. 180 degrees in a triangle. Do you see how this side is 18? That means this side is also 18. You can never assume that a picture is to scale. All right. So to get from the smaller side to the bigger side, you're going to multiply by square root of 2. So it is just 18 square root of 2. You just know that pattern and it saves you some work. We multiply it because we're going from the smaller side to the bigger. The hypotenuse is always the biggest side. So to go from the small one to the big one, you multiply. Now to go from the bigger one to the smaller one, you're going to divide. And we're going to do what's called rationalizing. I don't remember if we've done that already this year or not, or if that happened during the beginning part where I was gone. But you can't have that square root in the denominator. Do you remember how to get rid of it? You do this in algebra too.
You multiply, yeah.
Yeah, you multiply by square root of 2. You're going to do this so much. You're going to get really used to rationalizing. That's going to give you 18 square root of 2 over 2. The whole point is that these cancel and you just get 2. And then what does that boil down to? Yeah, 9 square root of 2. And if this side is 9 square root of 2, that means this side is also 9 square root of 2. I'm going to do the other pattern and then we'll do our break. I think we can make it through this first page. You're all staying with me here. All right. For this one, we do have A, B, and C because they're all 3 different. A is going to be the short leg, B is going to be the longer leg, and C is going to be the hypotenuse. So this is your 30 degrees and this is your 60 degrees. Do you remember small side goes across from small angle, medium side goes across from medium angle, and large side goes across from large angle? Remember, there's only 3 angles and 3 sides. There's only so much trouble you can get up to with a triangle. All right. Now here, what we're going to do for me to show you how this pattern works is you're going to draw in like a ghost triangle on the other side that is a mirror image of this one. We're creating a mirror image, like the triangle is looking in the mirror. So this is 30, and then this is 60, and this is 90. So if you look at the whole thing, what do you notice? Like this whole triangle here. They're all 60. It's 60, 60, 60. So if this side is C, this is also C, and then this is also C. Oh my gosh, that's where I was headed. Beautiful. Thank you. Love you. All right. So if you take A and you double it, you get C. So if you take A and double it, you get C. So if you take C divided by 2, you get A. I write it out both ways. If you really just only want this one, that's fine. Like you multiply to get to the bigger side, you divide to get to the smaller side. So before I write the last one, let's try that in a problem. Let's look at number 8. Do you see how this is the 30? That means this is the small one across from the small angle. So to get from the 18 to here, you're going to double it. So 18 times 2 is 36. And then let's actually go back to this one. To get from the larger side to the smaller one, you would divide by 2. So if this is 18, this side would be 9. Okay, cool. You just double it, and this is why. Now, to get the last one, we're going to do our Pythagorean theorem again. A squared plus B squared equals, don't put C squared. What did we just say that C equals? 2A. So we're going to write it like this. And then we're going to do some algebra. Hang in there with me. We'll do our break after this. I want to get to the end of this page here. So it'll be A squared plus B squared equals 2 squared is 4. So that's 4A squared. And then what would you kind of do next to get like your like terms together? Yeah, subtract that over. So it would be, 4 minus 1 is 3. And then we're going to do the same thing we did over here, which is square root. So B equals square root of 3 times A. So if you want to go from A to B, you multiply by square root of 3. If you want to go from B to A, you would divide. Again, if you only really want to write this first one, that's okay. Like when you go to the bigger one, you multiply. When you go to the smaller one, you divide. I'm just going to say that a billion times. Bless you. When you go from the smaller one to the bigger one, you multiply. Making it bigger means you multiply. So looking down here. Yeah, well, that's your pattern of how you get back and forth. Now we're going to go and fill in the rest of these. Now notice, you can get from A to C, and you can get from A to B. Can you jump directly from B to C? No, and I hadn't explained this yet. That's why I skipped this one. Okay, you can go from A to C, and you can go from A to B, but you can't go from B to C. It won't work that way. So let's look at this one here. Let's look at 8. Our A side is 18. Here, if you even want to label these, you can. That's A, that's C. We're looking for B. To get from the smaller one to the bigger one, you're going to multiply. So it would just be 18 times the square root of 3. So what would this one be if you apply the same pattern there? Yeah, 9 square root of 3. I skipped this one because it's a little tougher. You're starting out with B in this one. This is the one across from the 60. So to get from B to A, you have to divide by square root. That's why it's a tougher problem. That's why I saved that one for last, because you have to divide starting out. So if you rationalize that, use the same logic we did here, it would be 18 square root of 3. Perfect. Divided by 3, and then that would reduce down 6 square root of 3. Perfect. Now don't stop listening to me. Last one. To get from A to C, look back at your picture. You just double it. So 6 times 2 is 12. The square root doesn't change, though. You just multiply the whole thing by 2. Just 6 times 2 is 12. Don't stop listening to me. Let me answer this question, and then we'll do our break. Go ahead. So hold on a second, because I want everyone to understand. You'll be okay. I'm going to give you a break. Just don't stop listening to me. What was it? 6 square root of 3? If you multiply that by 2, do you see how it's just those two numbers that get multiplied? Kind of just like the whole thing. If you wanted the part underneath the root to change, you would have to multiply by something that's also under a root. So in this case, what would that come out to? So you can combine stuff that's outside and you can combine stuff that's inside, but you can't mix and match. Okay. So go ahead and do your like 3-minute break and then that was a good place to break this. Then we'll do the rest of this.
That was a lot.
All right. I'm going to see what you remember about this. Oh, thank you. Sorry. Thank you for saying it nicely. So sine is opposite over hypotenuse. Cosine is what?
So it's opposite over adjacent. Adjacent over
It's adjacent over hypotenuse. And then tangent
is opposite over hypotenuse.
No, it's opposite over adjacent. Here, now, when I was in school, I didn't learn SOHCAHTOA. So can I tell you how, because I don't know how to spell that. I'm a bad speller. So here's how I learned it. Can you watch me point to this? It was Oscar has a handful of apples. Oscar has a handful of apples, because that's a sentence and I can remember a sentence. Okay. Now, I really wish that I get why the geometry teachers don't do this because they have enough else going on. But I really, really wish that in geometry, they could take 5 minutes and go, hey, but there's these other 3 and all you do is flip it. That's it. Because then when you get here to pre-calc and I start explaining these, everyone freaks out. They're the other 3 trig functions and they are simply the reciprocals. Also, let's have this conversation. I am going to correct you if you say sin, cos, or tan. No, I have a strong belief. Stand up while I say this because it's important. There is a connection between your thoughts, your words, and your actions. And if you say it correctly, you are going to think it correctly, and then your answers are going to be correct. Thank you for heads nodding because I'm right. Okay. So this one is cosecant. Cosecant is how that is said. You'll get used to it. And all you do is take sine and do the reciprocal. That's it. That's all that it is. It's just a new word to learn, and all you do is flip it over. I just wish in geometry they could take 5 minutes and say, oh, but by the way, there's these other 3, and all you do is flip it. All right. This one is secant, and it's the reciprocal of cosine. Oops. So it's hypotenuse over adjacent. And then this one is cotangent, and it's the reciprocal of tangent. So that is all that they are. It's just 3 new vocabulary words, and all you do is flip them. That's it. Cool. Okay. Nobody freaked out. I like it. I know, right? So when we look at this one, I even filled it out for you, and it's one of the locker combinations. Do you see 8, 15, 17? Do you see theta right here? That's a little Greek letter, which is theta. That stands for your angle. That is like you are here on the map. This is your point of view. You are standing here. I know you guys don't use physical maps anymore, but you know at the mall when you have that like thing and there's a little star, you are here. That's what that is, okay? So which one is the opposite?
15.
15 is the opposite. 17 is across from the right angle, so that's hypotenuse, and so then 8 is adjacent. I want this to go quick and easy. Sine is which number over which number? 15 over 17. So cosecant 17 over 15. That is it. You missed this, so I'm going to just recap it real quick. It won't hurt anybody else. There's 3 other trig functions, and all you do is flip them. That's it. Cosine is what over what? 8 over 17. So secant, 17 over 8. Beautiful. And then tangent,
15 over 8.
15 over 8. Cotangent is 8 over 15. Boom. Now, sometimes if those have square roots in them, you have to rationalize and do stuff with the roots, but you know, that's essentially what it is. All right, so solve for x. We are going to use the calculator here, so you're going to have to watch me type it in. You'll have practice typing it when you do your classwork. Do you see how the 37 degrees is the one that's labeled?
Yeah.
That means this is your point of view. You are here. That is your star. You are here on the map. X is the hypotenuse. 11 is the adjacent. So sine, cosine, or tangent, which one involves adjacent and hypotenuse? Cosine. So it's always sine, cosine, or tangent of the angle. So it's cosine 37 degrees equals 11 over x. Now I'm going to talk you through this once, and then after this, you're going to have to just remember how to type it because you're going to be doing a lot of typing. Mathematically, here's what happens. Watch me point to this. You would multiply the x to this side. So you'd have x cosine blah, blah, blah equals 11. And then how would you get the x alone? You would divide over the cosine stuff. So when I type this in the calculator, if your x is in the denominator, we're going to type 11 divided by cosine 37. How many decimal points? 3. And the first 3 that you see. First 3 that you see, it's called truncating. I'm going to speed that up with this one because we can fly through this if you guys just pay attention. Do you see how 32 is the one labeled? That's your star. You are here. That means x is opposite. 13 is adjacent. Which one involves opposite and adjacent? Good. Tangent of 32 equals x over 13. Now, x is on the top this time, so we're going to type it a little bit different. All you would do is take the 13 and multiply it to the other side. So I'm going to type in, if you want to watch, 13 tangent 32. And it is 8.123. These are 2 points apiece. I want the setup and I want the answer. You show me what you set up and then give me a numeric answer. Yes, I just took the 13 and multiplied it over. Let's try again. Do you see the 50.1 is the one that's labeled? You are here. That means x is the what? Opposite. 5 is adjacent. Which one involves opposite and adjacent? Tangent. Tangent of 50.1, it's always the angle, equals x over 5. And then how would I type? Yep, just multiply the 5 over. So it's going to be 5 tangent. I hate having to go back and forth with this calculator, but I am really happy you guys get Desmos. 5 tangent 50.1. 5.979. Truncating is great because you don't have to worry about rounding those 9s. It would be a mess. Yes. Oh, yeah, sure. Sorry. No. It's always sine, cosine, or tangent of the angle. The angle is what has to go inside there. All right, 60 degrees is you are here. That means we don't have the opposite. This would be the opposite, but we don't have that one. So how will I label the other ones? Like what's 11? That's hypotenuse. And then this is adjacent. So which one involves adjacent and hypotenuse? So cosine 60 equals x over 11. Good job. Let me slide this over. And perfect. I'm going to multiply. So what will I type? Oops, 60. 5.5. Now, why did it come out nice? It was a 30, 60, 90 triangle, which follows your pattern. So it turned out to be a cute one. All right, this time the x is labeled inside the triangle. That's still your point of view. Whatever angle is labeled, whether you have it or not. 7 is opposite. 12 is hypotenuse. Flip back if you want to. We only just went over it. Which one is that? Sine, cosine, or tangent? Okay. Sine of x, the angle, even though we're missing it, equals 7 over 12. Now, when you are missing the angle, the way you type it is with inverse sine. It's not any harder. You just have to know where that button is on the calculator. And it has a little -1 because that means inverse. Good job. All right, so everybody just watch. I'm going to go into the functions over here. And very nicely, all your inverse trig is right there. So I'm going to do sine inverse 7 over 12. Yep. So, and I love that you guys get that calculator. It is so much harder on these ones. All right, so it is 35.685. Now hold on one second. I'm not super picky about putting degree symbols all over the place. If you leave it off every once in a while, that's okay. But if it's your answer, I'd like to see it because I want you to understand that what you found is an angle. Is that fair?
Yes.
Like I didn't write it on all these ones, like in my work of the problem, but if your answer is an angle, I'd kind of like to see it so that you know what you found. But I'd like to see it. It's kind of like, I like to see your inverse notation, but if you don't put it, I don't take off anything. If your answer's right, I am so happy. Like you know what I mean? Yeah, go ahead. Our answer wasn't degrees. Our answer was a side of the triangle. So what I was saying is, see how this was tangent 32? If you don't put that there, I'm kind of okay with that because it's just going to get slammed in the calculator anyway. But if your answer, see, these didn't have units, but it could be like 8.123 feet or inches or whatever, but they just don't have it in the problem. All right. I was about ready to say that. We're about to do some word problems. So these ones do need units like feet, meters, yards, whatever have you. Angle of elevation is with the ground. Angle of depression is with the sky, which I wish we had a different word for that. But here's the thing, and I realize that the earth is round. We don't have any flat earthers in here, do we? Okay, good. I realize that there is a curvature to the earth, but you can go to the physics classroom and discuss that. We're not going to do that in here, okay? In theory, the sky and the ground are parallel. I realize the earth is round, but in theory, they are parallel. So your angle of elevation and your angle of depression are actually congruent. Thank you for using good vocabulary. Congruent. So they're actually the same thing anyway. Do you get what I'm saying? Do you remember alternate interior and alternate? That's what that is. All right. So draw yourself a right triangle. Do you guys have an imagination? Do you remember in Inside Out, Imagination Land? I always bring that up. I would die for Riley. Anyway, you need to have an imagination, all right? A ship is offshore from a vertical cliff known to be 100 feet high. So the 100 goes here, that's the cliff. This is the boat if you want to draw one. I'm not going to be able to draw a picture for all of these because I am not an artist, okay? You got to have an imagination. Your angle of elevation is 25. I don't care if it says elevation or depression. You put that angle at the bottom of the triangle. Do you understand me? They're the same thing and it doesn't matter. Put it at the bottom of the triangle. All right. How far, so this is our X, offshore is the ship. So X goes there. Sine, cosine, or tangent? Good. Tangent. Good job. Tangent of 25 equals 100 over X. The X is on the denominator on that one.
100 divided by 10.
Good. You guys listen to me. This is fantastic. All right. So it is 100, divided by tangent 25. So there we go. 214.450. And then read the problem. Don't make up units. How many was it? Feet?
Yeah.
Feet. So these are 3-point problems. One is for the picture. One is for writing this. I always get people that fight back and dig in their heels and don't want to write that. I typed it in my calculator. I'm not going to give you points. One for this, and one for your answer. No, you don't have to draw a boat. A triangle. I want a triangle. That's it. Okay. So go ahead and draw a triangle. What's up? Same thing. Doesn't make a difference because they're congruent anyway. All right, let's speed this up. A radio transmission tower is 200 feet long, or 200 feet long, 200 feet tall, same thing, whatever. How long should a guy wire be? Do you ever see those poles and then there's a wire attaching it to the ground? Or do your mom ever grow string beans and you have that like wire that goes to the ground? Anyway, that's going to be the hypotenuse. How long should the guy wire be? So how long is that? If it's attached to the tower, let me scoot this over, 10 feet from the top. So look, the thing is 200 feet tall, but you're attaching it 10 feet from the top. So it's actually 190. Do you see what I did there? Like the tower is actually taller than that, but you're attaching it 10 feet from the top. It's 200 feet tall, but you're attaching it 10 feet from the top. So 190. And then your angle is 21. Sine, cosine, or tangent? Opposite? Sine, good. Let me clarify that because I just heard this question back there or comment, whatever, but I know what the question is. If you have an angle, you need sine, cosine, tangent. If you do not have an angle, that's Pythagorean theorem. If you have an angle, you need sine, cosine, or tangent. If you do not have an angle and it's all just sides, that's Pythagorean theorem.
So like even if we're missing a side, there's no angle on the inside.
If you have an angle, sine, cosine, or tangent. Because that's the guy wire. That's the wire connecting. You have to have an imagination. Oh, sorry. Yeah, sorry. I had a whole bunch of questions and all right, how am I going to type that?
190 divided by.
There we go. 530.181. And was that one also feet? Okay. All right. You're standing on top of a building looking down at your friend. Angle of depression 56. I don't care which one it says. Put that angle at the bottom of the triangle. They are congruent. The sky and the ground, in theory, are parallel. Your friend is standing 40 meters away from the building. Use your imagination. Where does the 40 go? Yeah, the horizontal, he's on the ground, right? How tall is the building? Where does X go? Yeah, the vertical, right? There. Sine, cosine, or tangent? Yep. Tangent 56 equals X over 40. Good. And then we're going to multiply the 40 over. So what I'm going to type is 40 tangent 56. I'll read it for the people in the back. It's 59.302. Is this 1 meters? Yeah, just be careful. Might not be. I might save one of these for a warm-up next time. Yeah, you know what? We'll save the last one for a warm-up next time. So we're just going to do 18, 19, 20. We'll end with that. All right, a 25-foot tree casts a shadow. Use your imagination. Which side is the tree? Yes, the vertical part or the opposite. Yes, good job. Trees grow upward, hopefully. Now, I get weird things with this all the time. If I'm standing here, my shadow is going to be on the ground. I get people that make the hypotenuse the shadow. How could the shadow be floating? I'm not Peter Pan. Okay, anyway, the shadow goes on the ground. That's 38. We want the angle. So that's X.
I think this is not drawing for the.
No, because we need an angle. Tangent of X, good job. Because that's the thing you're missing. So when I go to type that one, I'm going to go in here to my functions, and they're right up front, so they're easy to find. Tangent inverse 25 over 38. So it is 33.340. Now be really careful, because I think it said feet in the problem, but we found an angle. So your units are not feet. Angles don't come in feet. It's degrees. And I get some people that will like to do this instead, just to be absolutely sure. Up to you. I'll take the little degree symbol. That's fine. But I need it in that case because that's your units. And just don't put feet. All right. An airplane is flying 10,500 feet above the ground. So where does that go? Yeah. The Y, the vertical part. Horizontal distance of that number, so that goes down here. And we want the angle. For the sake of time, I'm not going to type that one. Do you get that it would be the exact same as the one we just did, but with different numbers in it? Okay, I'm not trying to torture you. All right, we'll do one more. I used to say a basketball player is 6 feet tall, but then someone would always argue with me, about this distance from here to here. Can you just accept that it's 6 feet off the ground? Okay. So a basketball player is 6 feet taller. We're going to say his eyes are 6 feet off of the ground. He's at the free throw line, which is 15 feet from the center of the basketball rim, which is 10 feet above the floor. That's a lot to unpack. So hold on. He's 6 feet tall. Oh, there is going to be a 4. You're ahead of me, so hold on. He is 15 feet away from the basket, which is 10 feet tall. Now, hopefully you are like, hold on a second, Miss Cole. You said the entire rest of the year was going to be triangles, and that does not look like a triangle. You can make one. Do you see? This would also be 15. And then you can connect it so that you have a right triangle. Now, Smarty Pants over here already said what this distance is. This is 4. Why is that? Yeah, this whole thing is 10. He's 6 feet tall, so 4. And we want the angle. So kind of don't look at this part. You just want to look at the triangle. So sine, cosine, or tangent. Do you guys notice that we use tangent a lot? That's common because you hardly ever know what the hypotenuse is. So if you get stuck on something, you are like total crapshoot, you don't know what it's going to be, pick tangent if you're not sure. But you always have a 1 in 3 chance of guessing. All right, so tangent of x, good job, equals 4/15. And I'll go ahead and type this one in first. So it's tangent inverse with a little -1 of 4/15. So it is 14.931 watts. Who agrees?